chemistry. Today's discussion topic will be haloalkane and haloarene. The understanding part is okay, but what about the conversion, reagent, etc. etc. So that's made that video in the viewpoint of reagent, reactions, name reactions and the conversions. So what you need to basically concentrate about that and what these reactions are important and what you need to study. Depending upon that, I have discussed the reactions, name reactions, the reagent and the process through which mechanism the reaction is going, substitution or elimination, that thing. So let's go to the reaction. Haloalkane. Haloalkane can be prepared by various processes. From alkene, from alkane, from other haloalkanes and from alcohols also from acid. I have basically taken here your reduced syllabus. According to reduced syllabus, I am talking about the preparation of haloalkane. In part of preparation of haloalkane, we will see the processes, the reactions in two ways. First, what is the reagent we are using? From alkane to haloalkane preparation, the reagent we need is chlorine in presence of photolytic conditions, and the reaction passed through the mechanism, that one is radical pathway. So by the formation of radical, reaction proceeds. Alkene formation, from alkene, formation of haloalkane. From alkene we can form haloalkane by use of any halogen acid like HCl, HBr, HI, means HX. Hydrogen and halogen will be added and the type of reaction will be addition reaction. Then we have from other haloalkanes. Suppose we have chloroalkane, we want iodoalkane, we are using halide exchange method. For this we can use any source of iodine or bromide and we can use the halide exchange method. So the method is halide exchange. Here in the halide exchange method, two name reactions are present, that are Finkelstein reaction and Schwarz reaction. We will discuss about Finkelstein reaction and Schwarz reaction. Then we have in halide exchange reaction, the reaction proceeds through the process. The process is substitution reaction. From alcohols, from other alcohols, we can form haloalkane by using the reagent, Lucas reagent, that one zinc chloride, concentrated HCl, phosphorus trichloride, phosphorus pentachloride, sulfonyl chloride. For all the cases, the product will be haloalkane, but the side products will be different. And all the reaction proceeds to using Lewis acid and then substitution. From acid, we can prepare haloalkane by using silver salt of that acid and using bromine in CCl for solvent after reflux. By this process we can form basically bromoalkanes and the process is known as Hans-Dicker reaction. This one is also one of the important name reactions. Hans-Dicker reaction, this one is also important and one of the name reactions. Next we have three type of reaction: Wurtz-Fittig reaction or Wurtz-Fittig reaction. In first case, we are using alkyl halide and sodium. By using alkyl halide and sodium, just that two alkyl part will get attached and there will be formation of alkane. This one is the reaction of haloalkane. In Fittig reaction, we have taken aromatic halide, sodium and another aromatic halide. Two aromatic halide will get attached and will give you the corresponding alkane. And in the Wurtz-Fittig reaction, combination of both two. We are using aromatic halide as well as aliphatic halide. And here that alkyl part and aryl part will get attached and will give you the substituted aromatic group. Next we have name reaction. Let's see Finkelstein, Schwarz and the other name reactions, reagent, starting material, product and the reaction procedure. First, in Finkelstein reaction, I am taking here one of the example of ethyl chloride reacting with sodium iodide, where sodium iodide is the source of iodine, and in presence of acetone here and heat, that iodide will take place of chloride and here formation of ethyl iodide will form, and the reaction process is substitution reaction. In the substitution reaction, depending upon the haloalkane, it will be SN1 or SN2. In Schwartz reaction, we are using basically methyl bromide, and we can use silver fluoride as the source of fluorine, and by addition of heat we will get methyl fluoride. So in case of fluoride formation from bromide, we can use this process. Next, Hans-Dicker reaction. In Hans-Dicker reaction, we can use both the through Hans-Dicker reaction we can prepare both the haloalkane and haloarenes. In case of haloalkane, we will take the silver salt of acid and we will use bromine in presence of CCl4 solvent, and we will reflux it. Then we will get that bromoalkane. Here carbon dioxide will come out from this acid part, that's why decarboxylation occurs. So Hans-Dicker reaction pass through decarboxylation pathway. Suppose we are doing this in case of aromatic group aromatic acid, so we have CO2H, we have to convert it to silver salt, so CO2 negative Ag positive, using the same reagent bromine and CCl4, adding reflux. After reflux we will get bromobenzene. Interestingly, we can use aniline to prepare any haloarenes. Let's see how. First we have aniline, we have taken benzene with NH2 group. We can get from that diazonium salt, and from this diazonium salt, using two different reagents, we can get chlorobenzene and bromobenzene. And in part of reagent also we can get two type of reaction. In first step we are using sodium nitrate with dilute hydrochloric acid and 0 degree to 5 degree centigrade temperature. Then from diazonium salt, if we use CuCl HCl, the reaction we will name as Sand-Meyer reaction. If we are using copper bromide HCl, then also we will name that as Sand-Meyer reaction. But on the other hand, if we are using copper powder and HCl, the same product we will get, just the name of the reaction will be Gattermann reaction. And for bromobenzene also, if we are using copper powder HBr, and the name will be Gattermann reaction. There are some reactions of haloalkane. We have iodoform formation. This one is very, very important to study explicitly about iodoform. I will give you a video on iodoform. You can watch from that. Sodium hydroxide and iodine, it will give you sodium iodate as well as sodium iodide and water. That sodium NaOI will be used as the reagent. Then acetone will react with sodium hydroxide and iodine, will give you CHI3, that one is called iodoform, and sodium acetate as well as sodium iodide and carbon dioxide and water. That the same way we can form chloroform also. Formation of Grignard reagent. Suppose we have haloalkane Rx and we are using magnesium in presence of dry ether, we can get the Grignard reagent. That will be very, very important in alcoholic reactions formation. So RNGX, that will be called Grignard reagent. Next we have another important reaction. I have taken one of the example of propyl chloride. I have added potassium hydroxide alcoholic medium here. Propene will form. The reaction pathway will be elimination reaction, and in that reaction pathway the reaction can be of E1 type or E2 type depending upon the nature of the substrate. And if we are using potassium hydroxide aqueous medium, then the reaction will be substitution type of reaction. Here propanol will form, and this also can be SN1 or SN2 depending upon the nature of the substrate. Next reaction we have ethyl bromide. That ethyl bromide is reacting with potassium cyanide alcoholic medium. Then it will give you easily potassium plus cyanide minus. They are highly ionic, and cyanide carbon side, that cyanide minus will attack and cyanide will form ethyl cyanide. But if you have silver cyanide, then this one is covalent in nature, and attack will be from the nitrogen side, and here isocyanide formation will happen. And another miscellaneous reaction we have substitution reaction, where that if we have any haloalkane, halobromine, haloalkane, bromoalkane, chloroalkane, iodoalkane. If we are using ammonia, then substitution by amine group and here corresponding amide or amine will form. In our next video, we will discuss the question answer on this topic. So I think a revision is done, a quick revision through this video. And if this video is helpful to you, give a like and don't forget to subscribe if you have not subscribed yet. See the other videos from the description box, the link is given, and thank you for watching.